Hi, everybody, and thanks for joining this K2View webinar. We are going to start in 1 minute. Okay, so hi and welcome to K2View's webinar on synthetic data generation. Actually, this is the second in a series of webinars on this hot topic. My name is Gil Trotino. I'm Director of Product Marketing at K2View. And with me today is Yuval Perlov, Chief Technology Officer at K2View. Hi, Yuval.
Hello, everyone.
Great to have you here. Before we start, few logistics. First, in case you have any question, along the way, feel free to send these questions using the question mark tab at the top right, and we are going to try and answer as many questions as we can at the end of this session. During the session, we are going also to ask you some questions, so please share some feedback once we ask you to share a little bit with us about your plans around synthetic data. On top of it, there are two white papers which you can download. This can be done through the attachment tab at BrightTalk. The first paper is a recent IDC research on synthetic data. And the second one is our own white paper, which is a complete guide to synthetic data generation. So you are welcome to download these papers. And finally, the webinar is recorded, so you and your colleagues will be able to watch it later. So without further ado, let's start and let's see what we plan to do today. So following a very short intro, we will focus today on the main generation methods, the main synthetic generation methods, and we'll try to explain when each method should be used. What do you need to look for when you select a solution to support these methods? And also, we'll try to analyze the pros and the cons of each method. Then we are going to touch also on the before and after of data generation and highlight the importance of addressing the end-to-end synthetic data lifecycle. And finally, we are going to end up with a brief overview and a product demo of the K2View synthetic data generation solution. So we have quite a lot of things to cover. Let's start. Before we start, a few words about K2View. K2View is a data product and data management platform which helps large enterprises to liberate their data. Why liberate? Because enterprise data is typically scattered across many systems, locked within different applications and technologies, and we help organizations from many sectors, as you can see here, many industries, to deliver fresh, unified, and trusted data to support operational and analytical use cases. And this is to enable them to deliver personalized and profitable customer experience. Our platform can be deployed as a data hub, data fabric, or data mesh, and we also offer tailored solutions such as our test data management suite, which includes data masking as well as synthetic data generation capabilities. You can find us in various analyst reports, as you can see here, such as the Gartner Magic Quadrant for Data Integration Tools and many others. So let's first try to understand why are we even talking about synthetic data? Why should anyone spend so much time and effort and resources to generate synthetic data when one can just use production data? So there are multiple reasons for this. First, we know that there are cases where when real data simply does not exist. For example, when I need to test new functionality, when I need some data in a very early stage of developing new software, then this data does not exist in my production data. I need to create it from scratch. Sometimes my data exists, but for security reasons or due to some privacy regulations, it's not accessible. I just cannot access the data. There are cases where the data exists, the data is accessible, but the data is insufficient. For example, we may use synthetic data to broaden data sets that are too small for proper modeling, or to increase smaller populations within a data set so we can have meaningful analysis or better testing can be run. Data can also be imbalanced. We can use synthetic data to create training data sets that are more balanced than the real world data sets. And finally, we can generate test cases that cover a wide range or a wider range of scenarios than would be possible with production data. So these are some key drivers or some key reasons where we are going to use synthetic data instead or on top of the real production data. And I think it's a good time, Amir, if you can now just shoot the first question to our audience. And we'd like to hear from you guys now. And we'd like to ask you, how far along is your company in terms of adopting synthetic data? You can choose if you're just exploring synthetic data but haven't decided to use it yet. Did you decide to use synthetic data and you're actively exploring its implementation? Maybe you're using it for specific niche projects, or maybe you are in a stage that you are already using it across the board. Please share with us, let us know, and we will share with you the results of this poll at the end of the session. I will continue, but you can keep answering this question. So we know some of the drivers for synthetic data. Let's talk a little bit about what are the top use cases for synthetic data. And this is taken from the IDC report that I mentioned earlier. There are 4 key use cases or leading use cases for synthetic data. One is to use synthetic data to assist in software testing. The second one is use synthetic data for machine learning models. The third is to use synthetic data to share data across organizations in a secured, compliant way without exposing any sensitive or personal information. And the fourth use case is all about training and simulations. Here at K2View, we currently see interest mainly in the first 2 use cases. And this is where we are going to focus today, namely software testing and machine learning training. So we are going to today to dive a little bit deeper to these 2 use cases. And let's start with software testing. I know that in our audience today, we have a lot of development and QA people and executives that are dealing with test cases and test coverage on a daily basis. And the development and QA teams, we know, need high quality data so they can test their software applications. So what are the main reasons or drivers to go for synthetic data for testing? The first and the most immediate driver is, of course, to enable data teams to create wide variety of test scenarios without exposing any PII. So compliance, again, will be here the first driver. But think now also about cases where teams need to create new features and test them, or introduce new types that do not exist in production. For example, let's take a telco company that needs to introduce a new mobile data plan that requires changes both in the application as well as in the data schema. How can development and QA teams test this new functionality? They don't have this data in production. It's totally new functionality, therefore they may need to use synthetic data to generate this test data from scratch. Synthetic data also allows testers to deliberately introduce errors or anomalies into data so they can better assess software resilience and integrity. This is what we call negative testing. So it's another strong reason. And finally, sometimes you need just high volumes of data for load and performance testing. And once again, synthetic data can be a very good solution to address this. So we have some very good drivers around software testing. But let's talk a little bit about machine learning. And now, Yuval, I'd like to approach you because for me, it always seemed quite counterintuitive. Can you explain us how synthetic data can be used to accelerate machine learning and train machine learning models? What is the driver here for this use case?
Yes, of course. So machine learning, when you train machine models, you need vast amounts of high quality data. That's just the way it works. This is this is what the current state of the art in machine learning does. You don't explain what you need, just show the engine inputs and desired outputs and desired outcomes, and you need a lot of data for that. And this becomes a great challenge in obtaining this data, in obtaining the variance of data that you need, in obtaining real life scenarios. And luckily, the flip side of this is that we have this Gen AI set of tools that can generate new data. Now, it does seem a bit counterintuitive that you can use AI to create data that would then train AI and give it better training. And of course, if you feed it back to the exact same algorithm, you won't get anywhere. But there are very clear scenarios where creating variance of a set of data and then analyzing that and being trained on that is, because these are two very different techniques, actually generates a very positive feedback loop. A way to think about it is maybe around the statement of challenge yourself, right? You can learn a new skill and then create ways to challenge yourself and still gain new insights. I like giving the example of a math problem where you learn when kids learn to do simple arithmetics, they can then create variants of the exercises, try to solve them, and they are gaining skills from that, even though they're generating the questions. So definitely there are numerous examples where this feedback loops creates a very positive impact and enhances the speed in which we can train machine learning models.
Good, makes sense. Thanks, Yuval, for explaining this. And let's ask the audience once again. This time, we'd like to ask you guys, what's your primary use case, assuming you have a use case for synthetic data generation? So Amir, if you can send a second question on air. I would like to know if this is software testing indeed, data privacy and compliance, or do you look for synthetic data for machine learning model training, as Yuval just explained, or maybe data sharing, or creating product demos or prototypes, or any other use case? Please let us know. What is your primary use case? And you can keep on answering this while we are trying now to better understand some of the challenges around synthetic data, right? Yuval, I've presented synthetic data as something which can magically solve a lot of data issues and address a lot of needs for different use cases. But there are some pitfalls, there are some challenges. Can you take us briefly through what are according to your understanding, what are the main pitfalls for people who are using synthetic data?
The pitfalls are tightly coupled with the way you want to use this synthetic data. So, for instance, let's take the first one, which is lack of realism or inaccurate data in general. If all you want to do is run some performance test over your data, maybe you don't care much about this lack of realism. However, if you want to, for instance, train an AI model or you want to run some functional tests, or simulate some data in the organization and use it for BI purposes, this accuracy becomes really, really important. So you have to match the accuracy of your synthesis technique with how you're going to use the data. Time-sensitive information is always a difficult thing, especially around when you use the data. Use it always. If you use it in relation to now, then you have to start managing your timestamps and manage data aging correctly. So the time frame of the data you're looking at will match what you're looking at. Complex data relationships, that's a challenge for every technique. For every technique, you have to deal with these data relationships and data consistency. If you just manufacture fake data, you run a high risk of your data being out of sync across systems, across tables. So you really have to take care of all these interdependencies between data points and make sure they make sense. Of course, you always have to test and validate that your synthetic data is up to the standard you want. That's a challenge in itself, and it doesn't come for free. It doesn't come for free. Every technique has its own footprint and its own, I would say, footprint profile, but they are resource intensive. Whether you're taking real data, training a machine model, using AI, using any form of data movement, data virtualization, it's always extremely resource intensive, and you have to be willing to do that.
Right. Thanks, Yuval. Yes, we are going to dive a little bit into some of these challenges, like complex data relationships and the time-consuming. Once we cover the methods, so let's really now jump into the what we call the 4 main data generation methods. These are the methods we are going to focus on. I know that there are some others like agent-based modeling and statistical modeling, but we are going to talk about these 4 key methods and talk a little bit about data masking, which seems like the most immediate method if you need to generate compliant data based on your real production data and you want to mask it. Data cloning, we'll explain this method, which is great for generating high volume of data for performance and load testing. We'll also look into the rule-based method using basically user-defined business rules, which are used to better control the data that you generate and can be ideal for complex calculated fields and complex business logic where AI methods may not be adequate. And finally, of course, we'll touch on the generative AI, which are the AI techniques such as GPT algorithm, which learn from your production data, the relationships, the statistical distribution, the patterns, and then generate and create rich, realistic, and compliant data. So what we'll try to do is to go method by method to explain what are the main use cases that this method fits best, what are the key capabilities that you need to look for when you are assessing such a solution, and a little bit pros and cons. And Yuval, you will help me here with some of the challenges. And we'll start with data masking. As I said, data masking is the method that you use to protect sensitive information by replacing, obscuring, or scrambling your original data, your sensitive data, with fictional or altered content. And this can be used basically to support all the use cases. Data masking serves in generating compliant synthetic data by ensuring the privacy, compliance, and also preserving, of course, the original data characteristics because we are using production data. What do we need to apply data masking? We first need to discover this sensitive information. So we need some capabilities that will help us to do the discovery of PII, for example. Then we need to assign and apply the data masking functions. And something which some people ignore is we need to ensure also that when we mask, we keep the referential integrity, because sometimes we need to mask data which is spread across multiple sources, and then referential integrity is becoming really important. And Yuval, maybe you can help us to understand what does it mean and why is it so important for data masking to keep referential integrity?
Right. So I think the simplest way to think about it is with an example. So let's say you have first name in your system. And first name is obviously a PII. It's a personal identifying information.
Right.
So you want to mask it. So let's say in this case, you switch Yuval and now it is Gil. Now, if you have the same data point in multiple systems, and each time you meet Yuval, you will choose another very random name, then now you have a data problem in your target environment. So it can break, maybe it can break a functional test where a system expects the first name to be the same in multiple systems. It can break reports where sometimes you see this one, sometimes you see the other. It can break even queries, join queries that assume something about the coherence of the data. So you need to make sure that you change it very consistently. The other side of this issue is that you have to do it well enough so it doesn't become a way to understand what the PII is, to uncover the PII back. So it has to be random enough, but then you might not want to repeat it for different scenarios. Maybe in different target environments, you want to mask with different names, so you cannot correlate data across environments. So there's a lot of capabilities here that try to strike the balance between referential integrity and not give away too much of your PII information in target systems.
Right. Thanks a lot. So okay, so we need the consistency when we anonymize this the PII, such a first name or last name across different systems, and you need to avoid this the de-identification of the data. So if we summarize briefly data masking, the pros are very clear. It covers data privacy and data compliance, and this is great. It also maintains the statistical properties of the distribution of the original data because it's derived directly from production data. The cons are that you need access to production data, of course, in order to mask it, and that you can't generate new variations or scenarios. Okay, so data masking is definitely, I would say, very strong candidate for some use cases and some scenarios. Entity data cloning is very interesting. We basically here take a single business entity, such as a customer, for example, with all its data across all the different source systems. We extract it, we mask it, and then we duplicate it as many times as we need. And this, of course, will be ideal when we need to generate high volume of data for performance and load testing. When you don't really care about the data diversity, you just really care more about the volume and, of course, about compliance. So, Yuval, entity data cloning is quite unique. Can you explain a little bit why K2View is uniquely positioned to support this approach?
Right. So the obvious first step is that we are an entity-based data movement solution, right? So when we look at the world, we don't look at tables. We always look at business entities. So we always model upfront the various objects, the way they relate to each other over a business entity. So let's take customer, for instance. We model upfront how a customer is modeled across the entire landscape. So that's the first key capability. Then there is a problem with the keys that happen behind the scenes. Every database has some kind of key system where rows or objects are identified with the unique identifiers. Now, if we write the same data again and again, we're going to just overwrite the same data again and again, and we're not going to get multiple entities. And this is where you have to be very precise about how you generate keys and how you generate them in a way that still maintains the relations between the original relations between the objects. And both of these together ensure the data validity, ensure that you're getting a customer that's on one hand an exact copy of your original customers, but you're getting enough copies of it to fulfill your use case.
Yeah, great. And we'll touch more about the business entity approach and how this serves to ensure data validity and referential integrity. But if we summarize entity data cloning, it instantly generates large amount of data, but the cons is that once again, you need access to production data. You get limited data diversity just because you use cloning, and there is some risk for de-identification, some privacy, data privacy risk. Now let's move to the more advanced methods. And the third one would be the rule-based data generation, which provides basically a structured way to generate synthetic data while controlling the generation process. And what we use here is we define specific rules that will be tailored to your requirements, to your compliance needs, to the different use cases. And actually, this is potentially the only method that you can use if you don't have access to production data. And again, two very good examples that we mentioned earlier for software testing is when you need new functionality testing, you don't have this testing data in your production data, and when you do negative testing. And what we need here is actually we need a very robust rule engine that will enable our users to define these business rules from different types. We'll have the need to customize these rules based on specific requirements and use case. And of course, we'll have also to support complex relationships. Robust engine, Yuval, can you say a few more words about what is needed in this engine?
Sure. So on the one hand, you have to be very, I would say, robust or complete with the rules for data generation you bring to the table up front. You can never get 100% coverage for very exacting enterprise implementation. So you need the system to be easily extensible, and to allow it to be easily extensible. So if for every new rule you have to have a CS degree in Java to be able to create this rule, you've missed the mark. It has to be expressive in a way that business users can create new rules. And while it is labor intensive in a sense, because you do have to think about every column, a key capability here is to add a lot of automation, to be able to profile the data automatically and feed that into the rule generation, to be able to have an out-of-the-box response for every type of column and let the user fine-tune it, so you don't have to start building it from scratch, but you get a first shot at what it should be. And once you have a good discovery engine and the way to extend the rules and also feed them back into your discovery engine, so once you have a new rule in place, you can feed it back, and if you discover the same data type again, you will apply the same rule. It becomes the whole solution becomes quite manageable.
Thanks for explaining this. So rule-based can create large quantities of data without having to access the production data. It provides precise, very good control over the generated data. But the two big cons here, it requires a quite detailed knowledge of the data and the logic needed to create it. You actually need to define very specific rules for almost every field that need to be generated. It's labor intensive, it's time consuming, so very powerful method, but also has its price, as you previously mentioned, Yuval. And this brings us to the fourth method, which is generative AI. generative AI can create synthetic data by learning the underlying patterns and structures from production data without actually directly copying or retaining sensitive information. So it can generate diverse data sets that capture the statistical complexity and variability of our real data. So these machine learning models are trained normally on subsets of our production data, allowing them to learn the underlying patterns, the correlations, the statistical distribution from the original data. So the use cases that fit best here would be when real data has a complex structure and when you really need a wider range of diverse data which you don't have within your production data. And the key capabilities will be basically to first subset the data. So you are really taking the right data and the focus data and the tailored data that will help your machine learning models to be more effectively be trained. You need to mask the data for compliance. Then you need to do the training. And in some cases, you will have also to apply some business rules to complement the Gen AI, and we'll give some examples later. And then probably a combination of both methods would be the most ideal solution. So the pros will be, again, you get high realistically data, very diverse. The speed, the time to generate, once you trained your models, it will be very speedy and requires less manual intervention, of course. The cons, yes, it also needs access to production data for the training, and it's an iterative and lengthy training process, which also requires domain expertise, but can be complemented with rule-based, especially if you need to uncover some very complex business logic, which Gen AI cannot fulfill, and the rules can solve this and address this challenge. So these are the four methods we wanted to cover. And just to summarize, let's try once again to take the key use cases and try to match them against the four methods. And once again, rule-based method probably will be great for cases when real data does not exist or you cannot use it for compliance reasons. So these are the first three cases we have here. Gen AI and masking can be used if you need simple model training and data sharing and analytics. If all you need is to ensure data privacy and compliance, you may just go directly with masking. Probably it will do the job. And finally, if you need high volumes of data for load testing, potentially cloning and masking would be the ideal solution for you. We also tried to summarize this using this decision tree or flow chart, which goes like this. If you don't have access to production data, probably rule-based would be the only method out of these four which is viable. Do you need high volume data? If you don't need high volume data, just do subset and mask your production data should be probably enough. If you need variety, data variety is really required. So if it's not required, just clone the data and it's enough. If you need data variety, then again, do you need a wider range of diverse data compared to your production? If no, just mask your production data. If yes, generative AI may be the solution. So again, you may go through this flowchart later on. This is one way also to provide some decision criteria that will help you to find what's the best method based on your specific requirements and use case. Now I'd like to leave a little bit the topic of the generation methods and touch on something else. And again, most synthetic data vendors today in the market really focus on generating the data, leaving a little bit aside the complex phases before and after. And here we want to say something about this. Some of the more complex phases around data preparation, data provisioning, and also the ongoing operations around the data are very critical if you want to be successful in deploying a synthetic data generation solution. And we call it the synthetic data lifecycle. It starts with preparing the data, right? The main stages here are, first of all, the data extraction, which requires integrating with your company's databases, technologies, and applications, and the need to extract the data, then to mask it, to make sure that you protect from the, you are not exposing any PII, and preserve privacy. Then you need next to subset this masked data so that the specific features and distributions and relationships that you have in production will be captured to train your machine learning models. All these stages are really necessary even before you start generating your data. So extracting the data, masking it, and subsetting it, these are crucial steps. Then, of course, you have to generate the data using one of these methods or a combination of them. And then you have to start using the data. Okay, and this is what we call synthetic data operations. First, you need to efficiently deliver the data that you generated to your target systems. Okay, this requires also careful data orchestration and integration to your different systems. Sometimes you will have also to transform the data. So you need some data transformation capabilities just to align the data to the specific formats and structures of your target systems. Okay. Again, depending on the use case, you may also need to establish some capabilities for reserving subsets of synthetic data to preserve others from overriding it. In many cases, we see customers that also need data aging capabilities, and sometimes also data rollback mechanisms that are essential to revert changes made to the generated data in case you have errors or you have the need to go back to a previous version of the data. So all of these capabilities of synthetic data operations are also critical. And in summary, what we see is that for a successful deployment of synthetic data, yes, you need a very robust generator, but you also need to address these intricate steps of preparing and managing data in operational environments, which are all very equally important. And this brings us to give you just a very brief idea about the K2View solution for synthetic data management. Yuval will demonstrate the solution very soon, but just to tell you that our data management platform organizes and manages data by business entity. It's a unique way that we use to manage the data. Business entities can be anything in your organizations, things like customer, device, order. And the business entity data models serve, in our case, as the blueprint that help us to generate the data. So what we do first, we first model your business entities using auto-discovery for all the schemas of the data across all your different data sources. Once we have this through the auto-discovery, we also automatically classify the data. So for example, we know which data is PII, and we also have the ability to classify for other attributes. Once we have it, we are extracting the data, and we can actually generate data extraction logic automatically based on this classification of the data. And finally, we can apply the different data generation methods together with this unified schema to ensure that once we generate the data, we also keep data validity and referential integrity. And again, this is by design because it's all done through these data schemas and the business entities. And Yuval, maybe you can take us through this example, which looks a little bit complicated, but try to explain us again how the business entity model can ensure data validity and referential integrity.
Right. So in this case, we see data spread out over 3 different systems. So we have a Salesforce application where we manage our customers, and we have 2 DB2 databases, separate ones for payments and one for invoices. 2 separate tables. And what we want to do is keep this referential integrity over the entire data set spanning multiple systems. So when we provision synthetic data, we keep this referential integrity. And it starts at the basic level where you see that the keys match, where customer ID, lost the slide, but where customer ID is the same over the two systems. But it can be more intricate, where you can see that the aggregate over multiple systems has to match. So here we have a rule saying the amount of invoices minus the amount of payments is the total outstanding amount, and that's saved in a different system. And we have to make sure that the data is valid across systems as well. So it's a combination of strict referential integrity and a wider view of data validity.
Yeah, thanks, Yuval. I think this demonstrates it nicely. I suggest we go directly to the short product demo that we prepared, and I'll let you share your screen.
All right. So I hope you're seeing my screen. You're seeing I'll start with the studio, although
I can't see your screen yet.
You cannot see it?
No. Can you share again?
Try.
Yeah, now we can see it.
Better?
Yep.
All right. So you're seeing the studio window running in my web browser, and Studio is where you implement our solutions. It's where you run discovery. It's where you build the relations between the various systems, where you can create new masking techniques, etc. So it's where you set up your solution and then deploy to production. Right now, I'm going to show synthetic data creation using machine learning. So I'm actually using the studio here only to show a behind-the-scene look of the data. So right now I'm going over the invoice table, and I'm seeing some production data, the invoices. This is actual data from not a real production system, but as far as this system knows, this is their production data. And I'm now looking over the interface. Here it's called the billing DB interface. You can see it on the left-hand side, and I'm going over data over the invoices table, offer table, etc. And this data is the data that we will then feed to the machine learning algorithm. And now I'm switching to TDM. So K2TDM, that's once everything is implemented correctly, you go into the test data management solution, and this solution is geared. This specific solution is geared primarily at test data, where you want to provision test data in lower environments, from this system, you do not have access to the production data. You cannot see it. The UI doesn't allow you to. But I'll start with creating a new task. Now I want to train my system, but this is the exact same UI where I would use, where I can create tasks of other types. So in a very, very briefly, we can use this system to extract data, to generate data using synthetic rules, to load data to a target, to delete data from a target. We also have a reservation capability where we reserve data on a target, and now two testers using the same environments are not stepping on each other's toes. We can use the system to train AI, and then use that training to generate additional data using the AI model we just created. So it's one system that covers all these techniques, and what's common to all of them is that they work on the entity level. When we extract data from a source, we use we do it on the entity level. We move a customer from point A to point B. We choose a selection of customers. We don't just give our users a way to filter tables, but to filter the business entities. So when we say subsetting, we mean entity subsetting, and entity subsetting using business parameters. And that goes again to loading the data. When we delete the data, we delete the entire business entity. We reserve the entire business entity. We train our AI models using an entire business entity. And when we generate it, we generate a fully cohesive business entity. So right now we're going to train our system on 300 customers. So I'll give it that name. I'm going to use the customer business entity, and now I'm selecting which environment I want to extract it from. So I'll extract it from my source environment in this case. I'll give it some guidelines. So of course, I'm going to work on the entity level. I'm going to sync new data, and we also have the option to take the data that's already available in our testing data store, or we can do a combination of the two, where data that already exists in the store, we would use it, and we would add additional data from the source environment as needed. I can specify how long I want to retain the data in our system, as well as more advanced parameters. And I select my entity list. So right here, I'm going to go with something really simple. Just take 300 customers, and I will even create a SQL for that. But of course, we can do much more complex scenarios where we subset using business logic, using business parameters and more advanced ones. And last step, do I want to schedule this execution, or do I want to execute it on demand? And now I'm running this task. Now, running these machine learning models requires some pretty expensive hardware. So GPU enabled machines. And right now I'm doing it only on 300 customers for the sake of time. You would usually need a few thousand customers for the model to have enough data to be of good quality. So this can run anywhere between a few minutes or a few hours, depending on the size of your data. See, okay. Now the task is complete. I've generated the model. Nothing is yet created in my target environment. And the next step is to now generate new entities using this model. So let's give this new task a name. I'll generate 10 customers. And I now choose which environment I want to save my newly generated customer on. So this time, target is my target environment. And I select what number of entities I want. So 10 here, and which model do I want to use? So I want to use, of course, the model I just created, which is trained 300 customers. And I will run this task. Of course, I can schedule it for a different period, but I will run it right now. Let's wait a few seconds for it to complete. This is always a bit scary, but let's hope it does the trick. We're almost there. Yes. We see movement. All right. It takes a few minutes to sometimes allocate machines, but we are getting there. And again, this is really, really fast in comparison to a large data set, because we only created a few customers, but our customers are complete. I will issue a report here to just see that the data. So right now, we use the source environment to train the data. We move the data to our target environment. And now we're issuing reports directly to this target environment and looking at a few data points. So you see that we have first name and last name, which kind of makes sense, but are not the real ones. We have referential integrity. We have some generated text here. The from date and to date makes sense and kind of follow the statistical properties of the original data set. From date comes before the to date, etc. We can go in deeper into subscriber info. So we see change of a VIP status over time, offers that were made, and all of this is generated according to the data that was supplied during the training phase. All right, it's just data, so it's not as shiny as we like, but this is very, very useful if you now want to do, if you want to test, because it's data that's purely generated, fully compliant, and you can now go ahead and use that data for your test case. Makes sense, Gil?
Yeah, absolutely. Works great. Thanks for this demo, Yuval. Just before we continue, I want to share, I think the audience could see it already, regarding our questions. So the first question was about, how far along is the company in terms of adopting to synthetic data? So again, quite interesting. 39, almost 40% are just exploring synthetic data. 21% of the companies are actively exploring it in terms of starting implementation. 21% have already done some initial specific projects, but not company-wide, and 17% say that they really took it already, and they are what we call data-driven, and they have embraced it across the board, which is quite nice. In terms of the use case, this is, again, not a surprise. 65% of the audience here on this webinar are looking for synthetic data for software testing, compliance and data privacy, 9% only for machine learning, model training, 18% for sharing data across organizations, and 6% for purpose of demos, prototypes, or simulations. So this is really interesting. Let me share just one summary slide, and then we are going to open it and take some questions. I hope you can see my slide. So I hope that during the session, and specifically, after Yuval's short demo, we've managed to show and explain how the K2View solution for synthetic data generation actually addresses the end-to-end lifecycle of synthetic data, including the different phases, and we explained them. Once again, let me say, we have the sources, we have the targets. Before we generate the data, we cover all the data preparation phases, including extraction of the data, as Yuval showed us, masking the data in flight, and then subset it so it fits your specific business needs and can effectively be used to train your ML models. Then, of course, we support all the different 4 methods or any combination of them to generate optimized results of synthetic data. And finally, regardless of the method, we provide you with the tools to take the generated data, to load it to your systems. You can, again, subset it if needed, reserve it if needed, transform, age, and rollback. Everything can be, as Yuval showed us, everything can be driven from a self-service portal or through APIs, which we provide. So this is a little bit about what we wanted to share with you about synthetic data in general and a little bit about our solution. I will now go back. Let's just.
Do you want to switch to the questions?
Yeah, I will switch to the question. Yeah.
That's some very interesting questions. So,
have you seen some interesting questions?
yes, we have here a question. Actually, two different variations of these questions, which is touching on the ways we can combine techniques for better results, and this is a huge benefit of course picking a system that allows you that has all these techniques under your hands. I'll give you a few examples. One is combining data masking with the training side. So you could mask PII before you send it to training. This allows you some flexibility of where the training can occur. So if you want to train in the cloud, but for compliance reasons, you cannot send your PII to the cloud. But this is where your GPU machines are. You could mask them before you move them to the cloud for training. Another thing, whenever ML falls short, and it does fall short sometimes, you could use synthetic rule-based data generation to augment your machine learning for those things that it cannot do well enough, or for those places where you want variance that you cannot. There's no way to explain to the machine learning algorithm. So if I want only VIP customers in my machine learning, I would probably first subset my VIP customers before I send them to training. But if one of the fields has to have a very specific statistical distribution, I can then augment that with a synthetic data rule that will make sure it's using that distribution to post-processing. So all of these techniques in combination gives you a lot of flexibility, and you're kind of getting, you could get the best of all worlds in a single data set. So thanks a lot for asking that. Did you see? Let's go over.
Yeah, I think we have maybe some time for one or two questions. There is a question about asking, can you expand a little bit on the auto-discovery process of the data model?
Right. So the data discovery is basically, we haven't touched it at all. It's a complete model of its own. It serves our foundational systems in many places. And the nice thing is you only have to discover once, and all our tools are well integrated with that. It can get the original schema from directly for the systems. It can also get it from an outside the source. Let's say you have a metadata repository somewhere, so we can get it from there. I see your question about what happens if metadata is not available. So of course you could create it manually or extract it if it is available somewhere and you don't have access to the source. Once you have the metadata, we apply rules to that and try to find connections and profiling the data within the metadata framework. So of course we need data samples for that, but using those data samples, we can find the PII fields. We can also use the established column names if they are descriptive. We find relations inside the data using naming conventions, statistical analysis, of course, following the foreign keys in the source systems, using queries that go to the source system to understand these relations. And all of this together creates the model, which we then use again and again in our system. We use it once to create the business entity because we understand all the relations between the various objects and tables and APIs. We then mask according to what we have in the catalog. We generate synthetic data according to the rules we found out.
Yeah, I have to stop you before they cut us through. And again, thank you very much for being here with us. Thank you, guys, for being with this webinar. We hope you enjoyed, and let us know if you have any feedback or any question. Thank you very much. See you soon in one of our next coming sessions. Bye-bye.
Bye bye.